Okay, a 0.05 significance level is used for the hypothesis test of the claim that when parents use a particular method of gender selection, the proportion of baby girls is different from 0.5. Assume the sample data consists of 91 girls. In a 169 births, the sample statistic of 7/13 results in a z-score that is 1 standard deviation above 0. Okay, so part A says identify the null and the alternative hypothesis. Okay, it says the proportion of baby girls is different from 0.5. So is different is the same thing as not equal to. Okay, so part A, h sub 0 would be p is something, and h sub 1 would be p is something. So since this is different is the same thing as not equal to, h sub 1 will get the not equal to 0.5, and h sub 0 will get equal to 0.5. Okay, part B, what is the value of alpha? Well, alpha is the same thing as the significance level, which is 0.05. What is the sampling distribution of the sample statistics? Well, in all of these, we have been using a normal distribution. Okay, we have the same shape for every single one of them, so we've been using a normal distribution. Is this test two-tail, left tail, or right tail? Okay, well, h sub 1 is not equal to, so this would be a two-tailed test. Okay, what is the value of the test statistic? Okay, so it says the sample statistic of 7/13 results in a z-score that is 1 standard deviation above 0. Okay, well, there is two ways you could approach this. There's an easy way and there's a harder way. Okay, so if we look at, so this is E. Since we are looking at proportion, we could use z-score is equal to p hat minus p over the square root of p times q divided by n. Our p hat, so that would be a sample, so our sample statistic, that would be 7/13 minus our p of 0.5 divided by, okay, p is 0.5. To get q, that'd be 1 minus p, or 1 minus 0.5, which would be 0.5 again. So 0.5 divided by, okay, n, we're looking at 169 births. Okay, so when you plug this into your calculator, this will all come out to 1. Or you could have looked at in a z-score that is 1 standard deviation above 0. Therefore, your z-score will be 1. Either way, it'll come out to 1. Okay, and then what is your p-value? Okay, we'll go over here. So this is part F. So part F, what is your p-value? So we are in a two-tail test. So here and here. And what I need is my test statistics. So this would be z is equal to 1, z is equal to -1. Okay, remember with your p-value, if we come way back here, if we are in a two-tailed test, the p-value is twice the area beyond the test statistic. So the easiest thing to do is to find the area to the left, because I'm going to go back to my z-score table, and that'll always give me the area to the left, and then multiply that by 2. Okay, so we need to go back to our z-score table, and I need to be on the negative side. Okay. All right, so I need -1. -1 is right here, and it was just -1, so that's going to be my first column right here. So if you just go all the way down, and then over. So 0.1587 is my area to the left, remember left, of your z-score. So it's over here. Okay, so this would have an area of 0.1587, which so would this area over here since your normal distribution is symmetrical. So we could add those two numbers, or you can just take that number and multiply it times 2. But either way, that's going to give you your p-value, which that would be equal to 0.3174. Okay, there's our p-value. Okay, G, what are the critical values? Okay, G. So we are still looking at a two-tailed test. So I still have test statistics at Z is -1 and Z is +1. Okay, I need to go back to this right here. And it said that we were in a two-tailed test because h sub 1 was not equal to, which means that this alpha is in two tails. So when I go back to this table right here, I don't have to multiply by 2. I can just go ahead and come to this table. So my alpha was 0.05. Okay, and it's already in two tails. So I'll just find 0.05, and that will give me a critical value of 1.96. Now, since I'm in a two-tailed test, that's going to be -1.96 and +1.96 for my critical values. Okay, so my critical values are -1.96 and 1.96. Because if you're in a two-tailed test, you will always have two critical values. If you're in a left or a right-tailed test, a one-tailed test, you will have one critical value. Okay, last question. What is the area of the critical value? Well, if you go back to these right here, there's your critical value. Here's your critical region. Here's your critical region. If I add the alpha over 2 plus the alpha over 2, that gives me alpha. Here's your critical value. Here's your critical region. The area in the critical region is alpha. Here's your critical value. Here's your critical region. The area in the critical region is alpha. Okay, so part H, what is the area in the critical value or critical region? Well, that's going to be alpha. And alpha is 0.05. Okay? And last but not least, effect versus fail. Actually, this should be accept versus fail, not effect. So let me mark that out. This should be accept versus fail. So with our decision rule, we don't say that we accept the null hypothesis. We say we fail to reject it instead. Okay, because we can never really prove that the null hypothesis is actually the case, because there could be a certain event in which we didn't consider. Okay, it really falls down to, if you talk about the legal system in America, You are innocent until proven guilty. But you don't come out with being declared innocent. Instead, you are not guilty. That's the same thing with the null. We don't say that we accept the null. That's like saying, okay, the person is innocent. We say we fail to accept the null, which is the same thing as saying, okay, this person is not guilty. Just because we didn't have enough evidence to prove that they were guilty, or just because we didn't have enough evidence to prove that we needed to reject, so we fail to reject the null. And that's it.